Students, welcome back once again. We are now going to study the chapter 2 of our textbook, that is matter around us pure? So usually, and we are going to also deal with the subtopics in between, that is mixtures and their types, that is homogeneous and heterogeneous. Okay. So before we move ahead, we shall know that is actually matter or any substance which we are using in our day-to-day life, is it pure or not? Okay, so what do we mean by pure? Whenever you go out, when you are drinking something or eating something, usually our parents tell, or, our friends will tell that we are going to take only, pure juice, right? Or maybe the good, clean, pure coffee, something like that, right? So in our day-to-day life, actually, what do we mean by pure is we mean, or we, tend to suppose it as to be clean, okay? But in science, it doesn't mean clean. Okay, what exactly pure means here in science is that something or whatever we are talking about, whatever it is, let's say a substance. Okay, so we in science we consider that substance is only made up of one type of particle. So in science, a pure substance, for example, if you are eating a mixture, okay, so what do we expect from a mixture? We expect that it should be pure, it should be clean, right, in our day-to-day life. But if we talk about pure in science, a mixture, right, isn't going to be pure. Or maybe a biscuit, or maybe if you are eating, vegetables, that is not pure. If you look, through the definition or the lenses of science, you'll see that that is not a pure substance. So substances that are having only one type of particle, those are only considered as pure substances. This other one would be mixture. Okay, so for example, the milk, okay, which we drink, we think that is the purest thing we are drinking. No, milk is also made up of different types of substances, and to be honest with you, a lot of water is there in milk already. Okay, and then your maybe milk made is adding a little bit more, right? So milk is actually a mixture. Then the air we breathe, we think the air, pure air, if I'm living, maybe in a countryside, if I'm not living in city. Okay, so if I'm living in city, people will say the air is not pure here. But if you go to a countryside, people will start saying that, oh, the air here is so pure, right? But that is not the case. Air is also, if you will see, air is made up of carbon dioxide, nitrogen, right, oxygen. So lots and lots of, you can say, compounds or molecules, right? So air is also not pure because it is not made up of only one type of particle. Okay, so these all, the soil, okay, beneath us. So the soil is also a mixture because you'll see a lot of rocks, you'll see a lot of humus and dead and decaying matter there, right? Soil is also a mixture. So if we tend to classify or divide, broadly the matter, you will see that matter is divided into two types. Okay, the first one is pure substances, and the second one would be mixtures. Okay, now pure substances, under this only one category that we have to study or see, that is solutions. Okay, sorry, just a second, let me erase this. Okay, under pure substances, we'll see elements and compounds. Okay, that we'll see later. Under mixture, there are two types of mixtures. Okay, homogeneous and heterogeneous. Two types of mixtures. Now what we'll see the difference between them. Okay, so let's quickly move ahead. So pure substances, like I already told you, they have same type of particle, whereas the mixtures have only two or more substances mixed to it, right? Then pure substances have fixed composition. What do we mean by that? For example, let's take water, H2O, water. Okay, so it has a fixed composition. Now, if you will go to Himalayas, okay, and if you are taking water there, right, from there maybe. Or if you are going to desert and bringing out water from there, you are taking the water from river, you are taking the water from lake, maybe tap water. Every water you are taking will be having the composition of hydrogen and oxygen, that too in fixed form. That means two hydrogen will combine together with one oxygen to make one water molecule. Okay, so this is in fixed compound. Now let's imagine a mixture. We are eating mixture, right? So in mixture, you will eat a lots of nuts will be there, right? Maybe peanuts are there, maybe, some other kind of nuts you are using, seeds. Okay, so you are like combining everything together and then eating that mixture, right? So it has variable composition, and it is not supposed to be fixed, right? So it's not like you are going to add only 4 peanuts to your mixture which you eat. Okay, it can be more than that, or maybe it can vary, right, depending on your like or taste, or maybe just how much you added. Okay, now mixture, again coming to pure substances, cannot be separated by physical means. So you cannot, maybe evaporate this water and oxygen and separate them out. Or maybe you cannot just hand pick those, right? You cannot just simply pick hydrogen by hand and remove it and oxygen by hand and remove it. No, you can't do that, right? So that means they cannot be physically, separated out. But mixture through evaporation or different other methods, which we can use, or maybe hand pick as well, we can, remove it and separate it out. Now, if we see the example of pure substances, the examples would be distilled water, like I told you, sugar, oxygen. These are made up of only one type of particle. Okay. For example, sugar is made up of glucose and oxygen is made up of O2, right? Glucose, like you can write it the full word. Okay. Now coming to examples. So of mixtures basically. So here example would be milk. See. Now, milk is not a pure substance, right? If you see through the lens of science. So it is a what? It is a mixture. And what sort of mixture it is, we'll see later. Then there is air. So air I already discussed, right? Soil also I told. Lemonade is also a mixture because you are adding 2 or 3 components, right? You are adding maybe lemon juice to it. You are adding sugar, maybe a little bit, a pinch of salt sometimes, right? And then you are adding water. So everything is being mixed. So even, like if you think that it can be very pure lemonade, okay, you have bought or maybe you have made with very cleanliness and all, but that is not going to be kept under pure substances. Okay, so I hope this is clear so far. Moving ahead, so there are mainly 2 types of mixtures. Now under this we'll see solutions and the other one. Okay, so 2 main types of mixtures are homogeneous mixture and heterogeneous mixture. Let me tell you what do I mean by that. Okay, so let's take this one, box maybe, and another box. Okay. Now, in homogeneous mixture, I'm telling you the composition is same, or you can say uniform throughout. Okay. So let's say this is, salt particle. Okay. And here, let's say this is sand. And both are mixed in water. Okay, let me just change the color of the pen. Okay, both are kept under, mixed in water basically. Okay, now what happens here is in homogeneous mixture, you are seeing that each particle is dissolved in the water in a uniform composition throughout, from top to bottom. You will see a pattern, you will see a uniform composition. Here in heterogeneous mixture, you will see that the molecule or the particles of, the solute, we'll discuss what exactly solute is later in later sessions. But here you will notice basically the sand is not uniformly distributed throughout the water. Somewhere it is, collected and being settled down at the bottom, maybe, and some particles of the sand would be, still like those small particles maybe still floating with water. Okay, so here you will see there is no uniformity in the composition of the solute you can say, or basically here you can mention as sand. Okay, so this is the difference. Now let's move ahead and go in depths of it. Okay, so homogeneous mixture, I have already told that having a uniform composition throughout. Okay, throughout, and cannot be seen separately. What do we mean by that? Once you're mixing salt with, okay, again, let's take the topic, the example from our previous classes, if you have taken, So what happens is basically you are adding up the salt with water, right? Now once you're mixing and stirring, there comes a point where there won't be no more salt, you can see. No more salt would be, oh, sorry, 1 second. Yes. 1 second. Be visible. Okay, so no more salt would be visible, right? Now, the examples here could be salt and water. We have discussed this, right? Just now. Sugar and tea. Sugar and tea also you cannot, once it has been mixed thoroughly, completely, then you cannot see the sugar particles in tea. Okay, because it is, again, you can remember the concept of, solids and liquids. So you remember that liquid particles have spaces between them, not too much, but still enough spaces. So what is happening if this is, water molecule or the particles? So what happens? The sugar will go and mix somewhere here in between the intermolecular spaces. Okay, so that's why the homogeneous mixture, we are unable to see, okay, the particles. Okay, air is also an example of homogeneous mixture. What would be the features? Features would be same appearance throughout. So throughout the whole cup or glass or whatever you are stirring everything in, you will see the composition of homogeneous mixture would appear same. Okay, particles are too tiny to see with naked eyes. So the solute particle, solute again, we'll discuss what exactly it is. But for now, let's say the sugar particles maybe, okay, or salt particles. So these particles are so tiny now that they are, unable to be seen by a naked eyes. You can't see them easily. And it is difficult to separate. Okay, not so easy to separate them. Okay, now let's move to the heterogeneous mixture. What exactly that is? So a mixture with a non-uniform composition, already I have discussed, right? Where components are visible. Now again, let's imagine, let's take a water, a beaker. We are putting water in it. Okay, water is there, right? Now let's add a, let's say what? Let's add these particles. Okay, this dust particles. Okay, so what happens is basically this particle, not exactly dust, you can say, soil particles. So this soil particle will start settling down at one place and it will be visible to us through our naked eyes. Okay, and it can be separated. So once you will start pouring gradually, or maybe you will filter out the whole, solution, you'll be able to get the sand separated from the water. So this is possible in heterogeneous mixture. So examples here would be sand and water, oil and water, soil and salad. Salad also you can pick out tomatoes maybe, and cucumber or onion separate. Okay. Okay, features. Components are distinguishable, may have different phases. Okay, one thing which we need to know is their phases could be different. Like something could be mixed in solid, like the mixtures example. Something could be mixed in liquid. For example, here sand and water, right? Or oil and water. So the phase would be different. Phase means what? This base which we are taking, in which we are adding something. So that we will study in depth in our classes. Okay. Right. Now, and it is easier to separate by physical method. Okay. Now, can you spot the different types of mixture? So lemonade, now you can, tell the difference. So lemonade would be a homogeneous mixture. Vegetable soup, You can see the vegetable, right, pieces. It is visible first of all, and you can hand pick also. So that is a heterogeneous mixture. Perfume, you cannot separate out. It is, even though made up of, different kinds of flowers and maybe, wood and everything is used to make perfume, but yet you are alcohols also, right, and oils, but you are unable to distinguish and take it out, right? So perfumes would be example of homogeneous, and pizza toppings that you can pick out, right? So heterogeneous. So again, what we have studied, let's, do a quick revision or a question. So milk is homogeneous or heterogeneous? It is going to be heterogeneous, and to be precise, it is colloidal solution. Okay, we'll see what colloids are. Which of these is homogeneous? Oil plus water or salt plus water? So again, for that, you have to recall that homogeneous mixture exactly is what? Okay, how it is different from a heterogeneous, and then you can remember. And the answer would be salt plus water, because the composition is uniform and you are unable to find the salt in water, right? Okay, so, and why is it important, everything, distinguishing the mixture and studying them, so that we can use these, techniques, different techniques to separate out the particles, different particles, and use it for our own benefit. For example, if we are picking, not picking, if we are extracting crude oil, okay, from the fossil fuel and everything, so we want to separate out petrol and diesel and use it for different purposes, okay? So for that purpose, we need to know about how matter can be classified and how it can be having separate, properties, so that we can separate them out. Then air separation for oxygen cylinder. Obviously, if you are unable to, study about the mixture, okay, air mixture, right, and if you are unable to separate out oxygen, how you are able to, make cylinders? You won't be able to, right? So for that also we need to study. For water purification as well, that what particle is not needed and how can we remove it, right? So again, we'll go in depth of it later. So far we have completed homogeneous and heterogeneous mixture under is matter around us pure. So hopefully you understand the session, and I hope that you will be able to now look around and classify at least 3 everyday things, and classify them as homogeneous and heterogeneous. With this, thank you so much, and you can contact me through my Urban Pro profile and learn more.